Today we are going to show you how electrostatic energy can move bubbles without touching them and explain why. The first step to the experiment is gathering all of the supplies. You'll need a PVC pipe, soapy dishwater, a drinking straw, a cloth, and a smooth surface. Having a smooth surface is important for the bubbles so that they can move smoothly without popping and so that the movement doesn't require as much energy. Next, pour some of the soapy dishwater onto the smooth level surface so that the bubbles can move. Take your drinking straw and put it into the remainder of your soapy dishwater. Suck some of the water into the straw without getting it into your mouth, and put the end of the straw onto the smooth surface. Then blow out slowly to create a bubble with a 1 to 2 inch diameter. If they're much bigger, they tend to pop more easily. Repeat the bubble blowing process again, so in case one pops, you have an extra one to experiment with. Next, I'll take the PVC pipe and move it around the bubbles. Notice how the bubbles do not move towards or away from the PVC pipe. Now I will take my cloth and wrap it around the PVC pipe while moving the PVC pipe up and down to create friction and generate a negative charge on the pipe. Triboelectricity, the transfer of charge through friction, is what makes the PVC pipe gain electrons. The pipe has a stronger affinity for electrons, so the electrons from the cloth move to the pipe, giving it a negative charge.
Then, when the charged PVC pipe is moved around the bubbles from about 1 to 2 inches away, the bubbles move towards the negatively charged PVC pipe. The bubbles have an overall neutral charge, meaning that there's an equal number of protons and electrons. While the overall charge is neutral with the bubble, the charges can move around. Charges of the same type tend to repel each other, while opposites attract. The bubble is being attracted to the pipe by the force of the protons in the bubble and the electrons on the PVC. The electric force with the opposite signs tends to be stronger than ones with the same sign. This occurs in our example because of distance. Both gravitational force and normal force are also acting, and this keeps the bubble on the surface.